everyone, welcome. Today we'll be reviewing how to find the molar mass and molecular mass of a substance, as well as understanding the general idea of a mole in chemistry. By definition, a mole is a measurement of how many particles, atoms, or molecules are in a substance. The abbreviation for mole is mole with a lowercase m. 1 mole is equivalent to exactly 6.022 times 10 to the 23rd particles. This number is, of course, in scientific notation. If we expand it out, the number would be gigantic. It actually would equal 602 hexillion. But because working with such a large number with so many zeros would be impossible, we condense it and say 6.022 times 10 to the 23rd, and it makes it much more manageable to work with. By the way, this number is referred to as Avogadro's number. It's pretty important to remember that Avogadro is a very important guy. He made a significant contribution to the theory associated with the mole. So remember, this number represents Avogadro's number. Okay, so we know 1 mole tells us a quantity and represents a number. Think of it like this. 1 dozen eggs is much like 1 mole of eggs. 1 dozen represents the number 12, and 1 mole represents the number 6.022 times 10 to the 23rd. So we can say we have 1 dozen eggs, and we can also say we have 1 mole of eggs. Remember, a mole tells us the quantity and represents a number. We have 1 mole of carbon, and that would be equal to 6.022 times 10 to the 23rd atoms. We can also have 1 mole of a compound like CO2, and this would be equal to 6.022 times 10 to the 23rd molecules. In fact, we can have 1 mole of anything, and it will be equal to 6.022 times 10 to the 23rd particles. Notice how I use the words atom to describe 1 mole of carbon, molecules to describe 1 mole of CO2, and the word particles to describe 1 mole of anything. You can use any of these words to describe a mole of something because it's in the definition, but you must use the terms correctly. Particles is referring to both molecules and atoms. Particles is kind of like an umbrella, and molecules and atoms are underneath it. The definition of the word particle is a basic unit of matter and energy, such as molecules, atoms, protons, neutrons, electrons, or photons. The difference is atoms is used to describe one type of substance, like an element where all the atoms are the same, such as carbon. So carbon is only made of carbon atoms, so we refer to its particles as atoms. And molecules describes a compound like CO2. Carbon dioxide is made of 2 different types of atoms bonded together. If we have 1 mole of carbon dioxide, we have a mole of these molecules. So we refer to the particles in the compound as molecules. And 1 mole of anything, we can describe this as particles because particles is the general term. Remember, particles is like the umbrella term, and atoms and molecules are beneath it. Let's try some practice problems. How many atoms does 1 mole of gold have? Yes, 6.022 times 10 to the 23rd atoms. And how many molecules does 1 mole of water have? Awesome, 6.022 times 10 to the 23rd molecules, correct. Okay, so now that we have a general understanding of what a mole is, what is molar mass? Molar mass is the weight of 1 mole in a substance measured in grams per mole. That means grams and moles are proportional to each other. As one increases or decreases, the other does the same. Let's say we have 3 piles of atoms. Each pile of atom is exactly 1 mole. Therefore, we can say each pile of atoms is Avogadro's number, or 6.022 times 10 to the 23rd atoms. Now, let's say the first pile is all carbon atoms, And the second pile is all nitrogen atoms, and the third pile is all sulfur atoms. How much will each 1 mole of atoms weigh? Will there be a difference in the weight of each pile of atoms? So this number we know represents the atomic mass, but it also represents the molar mass. So 1 mole of carbon atoms weighs 12.009 grams. In short, we can write it like this: 12.009 grams per 1 mole. Nitrogen has a molar mass of 14.006, so 1 mole of nitrogen atoms weighs 14.006 grams. And we can write that out like this. Sulfur has a molar mass of 32.059, so 1 mole of sulfur atoms weighs 32.059 grams. Each of these that we just calculated are the molar mass. So each different element or substance is going to have a different molar mass. Okay, so just to reiterate this concept once more, let's look at sulfur right off of the periodic table. This number represents the atomic mass in AMU, atomic mass units. But it also represents the molar mass in grams per mole. Remember, this molar mass refers to how much 1 mole of sulfur weighs in grams. Our number is 32.059, so that means 1 mole of sulfur weighs 32.059 grams. Okay, so let's put all of that information together and see what we get. 1 mole of sulfur is 32.059 grams. 1 mole of sulfur is also equal to 6.022 times 10 to the 23rd atoms. Therefore, 32.059 grams of sulfur is equal to 6.022 times 10 to the 23rd atoms. So we can see there's a relationship between not only moles to grams, moles to number of atoms, but also grams to number of atoms. Okay, so let's use this information we learned to answer the next couple of questions. How many grams does 1 mole of carbon weigh? Use the illustration given. 12.009 grams, right? 1 mole of carbon weighs 12.009 grams because remember, that little number is grams per mole. So 12.009 grams per 1 mole. And how many grams are in 4 moles of carbon? We simply need to multiply 4 moles by the number of grams of each mole, and we get 48.036 grams. How many grams does 1 mole of zinc weigh? And just FYI, on the TEAS exam, if you're presented with a mole question, they will provide all the necessary information to make a calculation. No way do they expect you to remember the atomic mass or molar mass of elements. Right, 65.38 grams. 1 mole of zinc weighs 65.38 grams. And how many grams are in 9 moles of zinc? If we multiply the number of moles given by the mass of each mole, we get 588.42 grams. Awesome. So we've gone over how to find the molar mass. Now let's go over how to find the molecular mass. First off, what is molecular mass? Molecular mass is the sum of the atomic masses, the AMU, and the entire molecule. And just as a side note, remember atomic mass is equal to the molar mass. So how do we find the molecular mass? The best way to understand this is jumping right into some practice problems. So let's get to it. What is the molecular mass of glucose? The first step is finding these on the periodic table so we can get their molar masses. Now, we're going to break this compound down by each element one by one. Looking at carbon first, the little 6 subscript tells us that we have 6 carbon atoms here. So we're going to write down 6, and the molar mass is 12.009. So we're going to multiply 6 times 12.009, and we get 72.054. Next, we have hydrogen. The little 12 subscript tells us that there are 12 hydrogen atoms in glucose, and the molar mass tells us how much each of those atoms weigh. So we multiply 12 times 1.0078, and we get 12.0936. Oxygen has 6 atoms in glucose, and each weighs 15.999. So we multiply 6 times 15.999, and we get 95.994. We now have the individual masses of each different type of atom in glucose. Next, we just have to add them up to get the entire molecular mass. If we plug that into our calculators, we get 180.1416. However, when adding numbers, the rule of sig figs is to round to the least number of decimal places. To do this, we look at the number of decimal places in the numbers we add up and look for the least amount. So 0.054, 0.0936, and 0.994 seems like 3 digits is the least after the decimal point. So our answer will only have 3 digits after the decimal point. And that's the correct number of sig figs. So we're going to round up to 180.142 grams per mole, and that's our answer. Let's find the molecular mass of calcium nitrate. First, we get our elements off the periodic table, and then we identify the masses one element at a time. Calcium has no subscript, so there is only one calcium in the compound. So we're going to write 1 times the molar mass, 40.078, and this gives you 40.078. There are 2 nitrogen, indicated by the number 2 subscript, so we're going to multiply 2 times 14.006, and this gives us 28.012. Lastly, oxygen has 6, so we're going to multiply 6 times 15.999, and we're going to get 95.994. We add these all together and get a total molecular mass of 165.084 on our calculators. This is the correct number of sig figs, so we're going to leave the number at that. And of course, we have to put our units, grams per mole, and that's our answer. Let's try one more. Let's find the molecular mass of ammonium phosphate. We have our elements off the periodic table for reference here. Starting off with nitrogen, we have 3 nitrogen in our molecule multiplied by the molar mass, 14.006. That gives us 42.018. Next, there are 12 hydrogen atoms here multiplied by the molar mass, 1.0078, and we get 12.0936. Phosphorus, we just have 1 atom, so 1 times 30.974, that's going to give us 30.974. Lastly, oxygen. There are 4 oxygen atoms in ammonium phosphate, so we multiply that by the molar mass of 15.999, and we get 63.996. Now, we add all of these masses all up together to get our molecular mass, and on our calculator, we get 149.0816. Our least number of digits after the decimal are 3. And by the way, if you're not sure what I'm referring to, it's these. 0.018 has 3 digits, 0.0936 has 4 digits, 0.974 has 3 digits, and 0.996 has 3 digits. So the least amount of digits after our decimal point in the numbers that we're adding up is 3. So our answer needs to have 3 digits after the decimal place. So our final answer is 149.082 grams per mole. Now, what if I were to ask you to find the molar mass of nitrogen in ammonium nitrate? Awesome, yes. 42.018 is the molar mass of nitrogen in ammonium phosphate. Okay, there is one last thing I want to share with you. It's probably something you're familiar with, and it's a very easy thing to remember. So, we have a chemical formula here, and do you remember what the coefficient represents? The coefficient represents the number of atoms or molecules on a microscopic level. However, it also represents the number of moles on a macroscopic level. Now, if you're confused and wondering why that is, I know it's confusing, but I'm not going to go over it in this particular video. So I will probably make another video on that. But for now, just accept the fact that the coefficients can represent both the moles and the number of atoms and molecules. So for example, in this chemical formula, there are 4 moles of iron that react with 3 moles of oxygen, and this creates 2 moles of iron 3 oxide. This last practice problem I'm leaving you with is from the official ATI T7 practice questions. It says, balance out the chemical equation. Which of the following best describes the number of moles of each product after the equation is balanced? So if we balance this out and look at the product side, also make sure you're looking at the product side. Don't accidentally select the answer that describes the reactant side, okay? So looking at the product side, we see we have 1 mole of magnesium chloride and 2 moles of water. So the correct answer ATI gave was written out like this. Alrighty, everyone. Thanks for sticking around. I hope you learned something new, and until next time.